Should be able to share now. There we go.
I go find it. It's in here somewhere. I just downloaded it. Okay. So before I start, I always have my brief little introduction. I will say I am not in any way a Halton Arp expert. I will try and answer questions as best I can, but most of this information is fairly new to me too. I did learn quite a bit about him, or at least what little limited information is out there doing the presentation prep, but unfortunately, with the exception of the catalog, he didn't. Well, I'll go into that, but there's not a lot out there on him that I was able to find. So if I miss something and somebody knows something about it, they're welcome to chime in. But for the most part, as I said, this is kind of a sketch outline of what I was able to find. Again, thank you, Wikipedia, for actually having an article on this guy, which was good. But it is he has sort of a mixed record. So he's born March 21st, 1927, and died December 28, 2013, age 86. And he's best known for the ARP Atlas of Peculiar Galaxies. I'm going to do the first section kind of going over his biography, and then we'll take a few minutes and have a look at the actual Atlas categories themselves. Now, the Atlas was published, I believe it was 1966. It was meant as an astronomical publication, probably for research scientists. I'm sure that in somewhere in the libraries and annals of several astronomical libraries, there's still copies of this thing. The list is available online, but that doesn't mean that it would be something that would be easily found because it is a little slightly outdated. We still use the terms and still refer to certain objects as ARP such and such, but I'll go into that a little bit too. One thing to point out with him, and one of the reasons he ran into a little bit of trouble, yes, Doug.
And of course, there's an Astronomical League observing program for ARP peculiar galaxies.
I was going to ask you that at the end because it would be
Oh,
a fun thing to try. And I do have a list of easily accessible objects, but a lot of these are very high magnitude objects. So it'd be interesting to see if people can actually pull them out with something like the 16. I suspect some of them are visible, some of them may be a little bit beyond that. So is actually a good thing to know is that it would be a fun thing to try for those who are looking for something that would be a little bit obscure and kind of some of these objects are pretty obscure, so this would be a cool thing to do. Some of them are actually very common objects that he cataloged in there that are nearby that we all know and love, and they're sort of intermediate as well. So again, he was born in New York City. He received his bachelor's from Harvard in 1949, his PhD from Caltech in 1953, and then he did a fellowship at the Carnegie Institute of Washington beginning in 1953. And later on, he did work at Palomar and Mount Wilson. Actually, that was part of the fellowship. I would assume the fellowship is essentially pretty equivalent to a postdoc by today's standards. Usually, they refer to those formally as fellowships, but they're often the same principle. He was then hired briefly as a research assistant at Indiana University. He did make a little bit of way up the system, but he eventually was then hired back as a staff member at Palomar in 1957, and he stayed there until 1983. And he retired early due to several disagreements, but one of them was over observing time. So, according to the information I found, he was not happy about the idea of having to submit proposals for time because he felt everybody knew what he was doing anyway. So, they eventually said, well, if you don't want to submit proposals for time, you can retire. And he did, and he was quickly appointed by the Max Planck Institute for astrophysics in Munich, where he lived and died until 2013. Um, Private life, there wasn't a whole lot about him. He was married 3 times. Don't know what that indicates, but he had 4 daughters, and he was very open about being his atheistic beliefs as well, as many modern scientists are. So he made two major contributions. The biggest was the ARP catalog of particular galaxies, and I'll go into some depth in that in the next section, because it is interesting to look at what he was doing with that, because it's not arranged the way we might do today, because they knew a lot less about the objects then that he was looking at than they do now. He was also surprisingly a longtime opponent of the Big Bang, going into his last publications in the 90s. The thing to remember is that when he was first writing about the Big Bang, it wasn't, established, universally in the community that it was the standard model of how we explain the beginning of the universe. Now, by 1990 and 2000, he was beginning to become sort of a fringe in opposing it. But he believed very strongly that the galactic redshifts that were observed were being caused by quantum effects near the supermassive black holes. And as I said, at first, the Big Bang Theory was not universally accepted. It was proposed earlier in the century. And by the time he came along in the 50s, it was gaining traction. By the time he was still writing books against the Big Bang in the 90s, he was very much on the outsides of the theoretical world. But he opposed it outspokenly until his death in 2013, long after the alternatives have been abandoned by most scientists. There's a small group that still believe in various theories that have to do with steady state and all that kind of thing. But for the most part, the Big Bang in one form or another, there are many Big Bang theories, but they're generally considered to be the sort of the gold standard. His firm opposition to the Big Bang theory may have been one of the reasons for his early retirement at Palomar. And ironically, most of his major books are about the redshift controversy, not about the catalog. So his published books were The Atlas of Peculiar Galaxies, which it was written in 1966, The Redshift Controversy, 1973, with George Field and John Bacall, Quasars, Redshifts, and Controversies, again, 1987. So again, this is a point where the Big Bang was becoming, and various kinds of theories like that were becoming sort of the standard way of understanding how the universe formed. Seeing Red, Redshifts, Cosmology, and Academic Science, 1998. The Catalog of Discordant Redshifts in 2003, and a Catalog of Southern Peculiar Galaxies, which covered the southern sky where he couldn't reach from Palomar, was published in 1987 with Barry F. Madore. He earned a few prizes and awards over his career, nothing hugely major. He earned the Helen B. Warner Prize for Astronomy in 1960, the Newcomb Cleveland Prize in 1960 as well, and the Alexander von Humboldt Senior Scientist Award in 1984. So certainly not anything approaching Nobel Prize, but he was somewhat noted in his time, specifically as an observer and for some of his lectures. So that is about as much information as I could find on the man himself. There simply was not a lot out there. There was, however, a little bit more on the ARP Atlas. Now, notice I'm calling it Atlas, not catalog. Uh, and one of the things that I found negligent in the articles I did find about him is there's very little explanation of how he collected this or in what format he presented it. By an atlas, I'm assuming he had star charts showing the position of things or pictures of this, showing the locations and the images. Certainly, whoever put the Wikipedia article did some effort to go find pictures, mostly taken by Hubble, of some of the objects, but it was not necessarily just a list of objects and their locations. There was some kind of pictorial element too. I could not find the actual atlas though. So the ARP Atlas of Peculiar Galaxies has an interesting history. As I said, there was not a lot of information about how the catalog was assembled, including the instrumentation. Now, the one thing I was able to find was that he was working on Palomar at the time, so he would have had some access to the plates that were being collected with the 40-inch Schmidt camera on site. So I'm assuming the general survey was done off of that, although I could not confirm that. I would guess he probably, if he got time on the 200-inch, then he would have been able to do some follow-up with that. But in terms of actually finding the galaxies, we can imagine that the Palomar survey of the era was going on. He would have had access to those plates. He listed 338 objects. Even at the time, it was not meant to be an absolutely comprehensive list of every peculiar galaxy in the universe. He knew that if you look further out, you'd probably be able to see more of these things. They are all galaxies. So unlike some other lists like the NGC catalog or the IC catalog, which contains a variety of objects, he was looking specifically at galaxies. He was looking at the northern sky as what was visible from Palomar. That doesn't mean exclusively the northern hemisphere of the sky, but what was visible with the telescopes that he had available. And by today's standards, these galaxies did not have super high redshifts. They were not extremely distant objects at the time. They were objects that could be resolved fairly well with the equipment at the time to show that they are peculiars. So by our standards of what we do survey today, these are not objects that are super far out, which is actually cool because most of these are objects that would be visible with, moderately sized telescopes up to about 40 inches. We actually do have a 40-inch telescope, but done at CAC. So I guess if you really wanted to tackle that, I don't know what the access rules for that though. Anyway, point being, at the time being, with the early to 1960s, not a whole lot was known about how galaxies formed. And ARP assumed that examining peculiar galaxies could give insights into how galaxies ended up as either spirals or ellipticals. And scientists of the day were still using the Hubble two-turning fork as to the basis for understanding galaxy evolution. The basic principle was that things tend to start out as ellipticals and then go off as either barred spirals or conventional spirals. Of course, we know differently today. It's not quite that simple. In fact, that model, although we still use the categories, does not necessarily give us as much information as we want compared to what we know now. But again, the purpose was largely to get an idea how galaxies form and create a list of objects that can then be followed up by other scientists, and I'm assuming including himself, to begin to look at morphologies and the like to get a sense of how these galaxies had formed. The important point is Arp was not trying to prove any particular explanation of how galaxies formed, although he had his biases, as we'll see when we go through the catalog. He is simply trying to provide a catalog of peculiar galaxies. Understanding the galaxies are arranged by morphology, and he has quite a few categories as we'll go through. But in meaning the shape and the form, he wasn't necessarily trying to arrange things by, what he thought was going on, just by what the shape looked like and what their appearance was. Most of the galaxies listed, not all of them, but most of them are now understood to be galaxy mergers, either currently ongoing or at least interactions. Not some of them aren't, but a lot of the peculiar galaxies out there that he listed are, in fact, because of interactions between galaxies. But he didn't know that at the time. In fact, there was a couple areas where he had some pretty far off predilections. He wasn't necessarily, again, trying to prove any particular theory, but based on the names he gave in the catalog, he kind of did give a hint of what he was thinking about with this. So, catalog arrangement. He started out with peculiar spirals. So the first 101 objects are various kinds of peculiar spirals. What he called peculiar, some of us might argue are just spirals, but he certainly seemed to think that they fell within a category. And again, if you look at the particular items on the list, of course, you can't show 338 objects in one PowerPoint, so I didn't even try. I tried to come up with some samples, and I know what a couple of these objects are. I think a couple of them are pretty recognizable. A couple of them probably aren't. Yes, my little bar of characters is in front of some of the more obvious ones, but as you can see, he developed over a dozen categories for each of the major groups that he put them in. The first one was low surface brightness, then split arms, detached segments, three-armed, one-armed, one heavy arm, whatever that is supposed to mean. I would assume it means that you have one large arm that wraps all the way around, that's much more significant than the other arms in the galaxy. Some that are S-shaped, has some with a low surface brightness with companions. There's small high surface brightness companions and large high surface brightness companions and elliptical companions. So again, he's not, again, it's all descriptive. This isn't meant to categorize any particular pattern other than, there's spirals, there's ellipticals, there's irregulars, there's things that he couldn't quite classify as the rest. But between that, most of the objects, most of the lists are not very long. So you'll notice that the first category, there's only 6 in there. There's only 5 or 6 in the second. So he's just providing, as good a sample as he could come up with this. I believe the object on the left is, I want to say M66, but I could be wrong. And we all recognize M51 up on the upper right. And the rest are considered spirals, of course, under better resolution. They might have been categorized somewhere else, but he was working with what he had at the time. So elliptical companions, looking at things with companions that were involved, was also involved. So spirals, he was just looking for things that kind of went away from the standard spiral morphology that was understood at the time, with imbalances or things that looked like they didn't quite fit with the standard category. Ellipticals, there are far fewer ellipticals in um, the list than spirals or any other category. Part of this is ellipticals are ellipticals, right? They're less likely to have some strange morphology and something that doesn't have a morphology to begin with. But he did pick up some interesting objects, ones that were connected to spiral galaxies, repelling spiral arms, probably through tidal effects. They did not necessarily fully understand that at the time. Of course, they understood tidal effects. It's just that they wouldn't have understood necessarily the whole process. And then close to and perturbing spiral galaxies, nearby fragments, again, tidal tails and emanating material. Again, these are, as we understand today, interactions between galaxies that caused various tidal effects. Now, some of the ones that we see are actually, and we'll come back to in a bit, have some other things going on. So, for like M87 on the top one there with the jet coming out, the jet is not directly related to a galaxy interaction, and but he didn't know that at the time, although we may have suspected, and some may have suspected at the time, that there was a very large object, in that case a very large black hole, which was blasting out that particular jet. Over on the right is Centaurus A, and I don't remember. I think it's 5137 in GC. It was not a Messier object, but I could be off with the number. But again, that one is still a little bit of a mystery. It is assumed that a galaxy collision of some type happened, but whether it's between two spirals or an elliptical and a spiral is a little bit of a debate. But again, a collision involved, and then along with the long tidal tails is probably two galaxies with the one of them being seriously disrupted by the interaction. And then on to amorphous galaxies. This is a very long list, and a very large part of the list. Again, he was looking for things that stood out as being strange or peculiar. Ones with associated rings, you only found a couple of those. Jets were also included in there. We know a lot more galaxies that have jets now than we did then, because you didn't have the magnitude penetration that we do today with some of the modern surveys. Interior absorption, so there was something blocking the light coming out. Diffuse filaments, diffuse countertails. Again, all these different kinds of categories. Material ejected from the nuclei, not necessarily the very nuclei of the galaxy, but the central bulge or whatever bright part that stuck out. Irregularities, absorption and resolution, adjacent loops, concentric rings. So a lot of weird morphologies he was able to pick out. I don't know if that shows the whole list on the screen, but it gives you an idea what was on there. And then double and multiple galaxies. How he broke this up seems a little arbitrary in certain places. Like, what is the difference between amorphous galaxies versus double and multiple galaxies. I mean, I get the principle, but in some cases where you draw the line may not be so clear. So he was definitely making decisions there about where things were going, where things were going to be placed, with things like connected arms and interacting galaxies. It seems like there have already been several categories about interacting galaxies, infall and attraction, wind effects. Again, the wind wasn't fully understood at that point, and so it was based on appearances, a large group of what he called unclassified galaxies, and also groups of galaxies. And remember, he wasn't looking at galaxy groups per se. There are later groups, I believe the Able catalog, which was looking at that. But that was a little bit later. But of course, if you're looking at groups, you're going to see some peculiar galaxies because there's a lot of gravity interactions and tidal interactions and chains. Just a few of those listed, and then his catch-all drawer, which was miscellaneous. Again, he probably could have included more objects than that, but he broke them up into finer parts. And again, on the right is some of the galaxy groups that were classed in sort of the double and multiple galaxies section. And that gets us to 338. So again, looking at the information that I found on the internet, things range from, galaxies that were 6th or 7th magnitude up to about 14th to 15th magnitude. So things like the M51, for example, very visible in the sky right now at this time of the year. You'd have no trouble finding with a small telescope. Some of these you would need a fair-sized amateur scope like the 16 or a 17 or an 18 to be able to go find them. Others might need something a little bit bigger than that to go looking for, but a lot of these are probably within the reach of fair-sized amateur scopes. Some of them are visible with smaller telescopes. And I did find a couple lists that have been put together of objects that are pretty obvious that are ARP lists on the ARP list. So these are the biggest and the brightest. Most of these actually these are very familiar objects, even though we don't think of them as ARP objects. For one example is M101 is ARP 26. He was well aware of the Messier catalog and the NGC catalog. He wasn't trying to make brand new discoveries with every object. He was simply trying to list objects that has some peculiarity. And where you call these peculiar, he had his categories. I would call them spirals, but in this case, M77 is number 37, M90 is 76. M51, well known, is 80, ARP 85, M87, the one with the jet we were looking at, 152. Centaurus A is ARP 153. Again, these are pretty much spirals and ellipticals because they're low numbered on the list. The list was not reflecting anywhere in position with the sky or any idea. It was just what category he felt they were under.
Oh, Stephen
And I
froze
think
up.
Stephen is frozen. We'll give him a couple of seconds and see if he recovers. Or if he ends up having to come back to us. Da-dee-da.
Other bright objects, according to Ray.
Hey, Stephen? Sorry, Stephen. Uh-oh. Hey, Stephen. Come on back to us.
Yeah.
Unmute, please.
There we go. Can you
Just so
hear me
you
now?
know, you froze up on us for about 2 minutes there.
Okay. Where was I?
You had
We're
the
on the second list of the
Yeah.
ARP objects.
Yeah, I think I was still going through rattling through that while we were.
Yes, you were.
So bright objects for amateurs from Pitt and Dre. Can you see me now?
We
Yeah,
see you. Do you
Okay.
need to get your presentation back up?
No, you just not Austria. I gotta share screen.
Yeah, I
Still
don't see the presentation.
Okay, just a sec. Let me go find you and then put the screen share. Yeah, that seems convenient. I think I've got 4 people using or 3 people using the Wi-Fi here right now. So
Well, looks
we're
like it's starting to come up.
probably at the bandwidth limit. How we doing?
Okay,
You're
you
up.
just need to make it a slideshow and you're good to go.
Make a slideshow from current slide. All right.
There, looks good.
All right. M32 is one of the companion galaxies to Andromeda, and then there's the antennae, which we actually were looking into the 14 a couple weeks ago. From TEMPA, you can sort of make out the bodies, you can't make out the tails or the antenna themselves. Some of the others are a little bit more obscure. NGC 485, 395, also M65, and M82, which isn't terribly surprising that they would be that one would be considered a peculiar galaxy because it is an off shape with all those weird dust lanes spewing out of it. The images you're looking at are all Hubble images. Obviously, Hubble came a lot later than 1966, but these are, again, well-known objects that have been photographed pretty extensively in the meantime. Some other ones I did a little bit of research on within the list. Some other notables are the tadpole. We are looking at that with that very long tidal tail. The mice, I believe, is over down on the lower left. M66, M49, the penguin or seagull. I always think that's a very pretty one, but it's really a faint object. You need a big telescope or the Hubble to be able to see a decent image of that. And the Medusa galaxy, NGC 4194. That one is very faint. It comes out much better in a big telescope, obviously, than some of our small ones. Other ones, I just like the name of this one, Atoms for Peace Galaxy. It's very remote. It is an NGC object, so it's not as remote as it could get, but it is not a bright object. The whale, which I actually have taken photographs with my S30, it's over. Where did I bring that one in here? I guess I didn't take that picture. Oh, yes, it's the one on the upper left. It does look like a gray whale if you look at it from a certain angle. That one has a companion which is distorting it. The Leo triplet, surprisingly, is also on the list. This is a very big, bright object we've all seen before. It's 317. Stephan's quintet. You can reach Stephan's quintet with a very large amateur scope, but it really is a tricky object. I've looked for it before and sort of seen some smudges with the 14 and the 16. But it is a little bit of a trick. Copeland septet. So over down on the bottom, the right, and the Pisces cloud, which is 379. So I promised Connor that I wouldn't just dump pictures in here of every object I could find. Yeah, I didn't necessarily want to spend hours going through images, and I also thought that this would give a good, decent sample of some of the objects that are out there. So that was the point where I was going to ask Doug if we have an astronomical league project on it. I think for you guys who've done a lot of astronomical league projects, it would be kind of cool to try with the 16 or something like that. So,
Okay, so I sent an email, I sent a chat out, but I'll just repeat what I said in the chat. There are two ARP programs, one for the northern sky, one for the southern sky. There's 100 objects in each list, and they say the minimum required size of telescope to use is a 12.5 inch.
I have two of those available at Temp. Anybody who's interested. So just to put a little plug out there.
Let me check
and
one
so
more piece of information. Give me 1 second. I'm looking.
Doug's getting that, Stephen. You have another question in the chat if you happen to check it.
I can't see the chat right now. What's the question?
I'll let Doug finish up his piece and I'll relay it to you.
Okay.
Okay, Doug's still looking, just so you know from,
Go
ahead,
ahead,
Doug.
take care of that while I'm looking.
Okay, yeah, Stephen Nelson was asking, might C-Star be able to image some of these ARP galaxies?
I've done a few of them, but not many. So most of these are you're gonna, as Doug said, you need a 12-inch telescope to be able to see anything that isn't on well, I don't want to say anything, but most of the things that aren't on the Messier list. As I said, I've done the Leo triplet, I've done 101, I've done 51 on the S30. So yes, but I would say there's maybe a dozen at most on there that you could do that with. That's probably pushing it. I've done the whale. I don't even know where the Adams Peace Galaxy is. It's not even on my star charts. I just like the name. Some of the other ones, obviously 66 I've done is and the like. 49 you could probably do. I think the Penguin Seagull is too remote. M32 comes up whenever we do a mosaic of Andromeda. I have tried the antenna on the S30. That might be one that would be worth looking at with an S50 for long exposure. Some of M82 I have done on there as a part of the M81, 82 group. But beyond that, I'd say most of these would be a little bit of a stretch.
Any
Okay,
follow-up, Nelsie?
4 people have done it in our club. Greg Ruppel, who is famous for imaging, you see his images in the bulletin all the time. He's done the Northern Arp program imaging. He hasn't done it visually. A gentleman named John Skillicorn, who I know is a well-known observer in our club, who's got a number of Astronomical League observing awards, never shows up to the meetings. I've actually never met the gentleman, but he's got like 15 different observing awards, and he has some large equipment. He has like 24-inch and stuff like that. He's done the Northern Arp. And then a gentleman named Tim Hunter, I don't know if any of you remember him.
Long
He,
time ago.
long time ago, he did it, and there was another gentleman who did it. There's 4 people who have done it from TAAA.
It's probably been a couple years since somebody's done it, so if anybody wants to
It,
take up the challenge.
yeah. Greg Rupo was the last one to do it, and he did it imaging.
Okay. Right. So, did I include, so I don't think I included much on the legacy of it. I thought I had included a section of that. But oh, the legacy of the Atlas. Again, it was never meant to be super comprehensive. ARP was not looking for every single object that would fall under that category, just a sampling that could be then examined later for morphology to kind of follow up with and get some ideas of how these things were forming or had formed. And the original catalog, because he was working out of Southern California, did not have full sky coverage. The list is still used occasionally. I have seen objects referred to under their ARP catalogs named, which is why I was interested in doing this project in the first place, exactly what's up with this ARP thing. But it was dwarfed by things like what's the one in New Mexico? Sloan and things like that, which had better magnitude penetration and spectra. He was not looking at spectra at that time for this. It'll largely fall in disuse probably with professionals. I think amateurs probably know a little bit more about it than the professionals would. At least in this day and age, I think there was a time when that might have been different. Um, but it was important in this time because many of the follow-up studies did track and get us an idea of what galaxy evolution looked like, at least in the nearby universe. Of course, it took the space telescopes and much bigger optics to look at the very early universe, and we're still piecing that together. But a lot of these objects did give us an idea of what galaxy interactions are and what they do to galaxy evolution. And that was the important part there, is at least in the nearby universe, it gave us a sense of how galaxies evolved due to things like collisions and interactions and the like. And my works cited was pretty much all of Wikipedia for this one. I wasn't able to find much else out there. Atlas of Peculiar Galaxies by Wikipedia, and I took everything from Wikipedia and WikiCommons. So that's kind of where we are at with that. I think that is the whole presentation. Any other questions?
Did you use any generative artificial intelligence for your presentation, Stephen?
I don't believe in generative
I know.
artificial. I don't want to sound like a snot, but I'm smarter than those little damn machines any day of the week. But
Yeah.
in terms of the now for image processing, the
Yeah.
computer's way ahead of me, but I don't do a whole lot of image processing other than just basic downloads and things like that. So that's one where I would say, and that's a whole nother topic we might want to do one night. Actually, I should do a presentation on that. Is like what is AI useful for amateurs? But there's a very small AI on the C Star that I really like, but other than that, I'm morally object to language models and the less. I think they're just going to dump down the world. But well, that's just me. If you want to do it for image processing, though, I actually think it does have some merit for that. But that's something that will save you a lot of time and the like. But I haven't tried that yet. Maybe I should take my C Star images and put them into Chat GPT and see what comes up.
There you go. Any other questions or comments for Steve? Great presentation, Stephen. Any other questions or comments, please?
So Pete, I'll send an email to Connor too, but I'm gonna ask him if I could do a presentation in like maybe, let's see, August, July, maybe August or September on the new astronomical lead program called Space Weather.
Oh, yeah.
I'm going to do that program right now, starting today. I'm going to build the apparatus and
Is this your program, Doug?
no,
Oh,
I discovered it when I was looking at the radio astronomy
oh, I know which one
program.
you're talking about. Go ahead. Yeah.
You start with one of
Yep.
these and you build a magnetometer and you measure fluctuations in the Earth's magnetic field as a result of sunspot activity and stuff. Seems like a really simple project, seems like a real simple astronomical lead program. You get a nice certificate and a pin, just like all the rest. So I'll give a presentation on that in a couple months after I've been doing it for a while. And I plan on doing a workshop too, where people can bring their own 2-liter bottle and build one of these things.
Okay. I take it that's the updated information because from what I understand, I remember seeing the initial, there were a few issues with what the sensor was able to actually accomplish. And so they came up with some updated information.
Not for this one.
Uh,
I just read the website today.
oh, okay. There was a slight modification. It's been out for about almost 4 months, Doug.
Yeah, that's all.
Yeah,
It's very
but
new. It's a brand new program.
yeah, there were some issues with the sensor itself, with building the sensor for detecting the magnetic fields or the fluctuations in the magnetic field. But that's neither here nor
Well,
there.
I'm not expecting any major variations, you know.
Oh
I'm
no,
expecting
yeah,
it's a pretty steady state, but who knows? You know, you
yeah.
might as a matter of fact, there was something on Yahoo today about there's a coronal hole in the sun's corona, and they're expecting a large geomagnetic storm Saturday.
Okay.
So I'm
I've
going
got
to
a
build my
question.
apparatus tonight and see if I pick it up.
I've got a question. I'm assuming that from what I know, the answer to this is yes. Can those low frequency radio detectors that we're working on with the radio group potentially pick up the disturbances in the ionosphere?
Yes.
Okay, I would
Yep.
assume that was the case. Yeah, I think we will
That's
listen
one
to
of the
that one. Yes.
projects on the radio astronomy website for the Astronomical League. One of the projects is to do the same thing this magnetometer is going to do, pick up disturbances from the sun in the from sunspots and stuff. Is you can use a radio telescope to do that too.
Cool.
So
Well, hope everybody joins us for the radio astronomy group. I'm not officially in charge of that in any way, but it'll be cool. It's gonna sounds like it's gonna be really cool.
well, I'm going to buy one of those radio telescopes in a box. It's only $300. I mean, hell, I pay more for that than for some of my eyepieces. So,
Hey, folks, before I stop the recording, are there any more questions for Stephen on his presentation?
Okay.
Going once,
Thanks,
going
everybody.
Yeah.